Hi, welcome all to the online classes. Today, I'm Mukesh Bhardwaj going to represent a topic correlation in the subject statistical methods, BSc Agriculture 5th semester. So far, we have studied some characteristics of one variable only. Example, mean of the distribution of height, standard deviation of weight, skewness of the distribution of income, but many situations arise in which we may have to study two variables simultaneously, say x and y. For example, the variables may be the amount of rainfall and yield of certain crop, the height and weight of group of children, or income and expenditure of several families, or ages of husband and wife, etc. There are two main problems involved in such study. Firstly, the data may reveal some association between X and Y, and we may be interested to measure numerically the strength of this association between the variables. Such as measure will determine how well a linear or other equations explain the relationship between the variables. This is the problem of correlation. Secondly, there may be one variable of particular interest and the other variable regarded as the auxiliary variable may be studied for its possible aid in throwing some light on the former. In such case, one is there interested in using a mathematical equation for making estimates or predictions regarding the principal variable. This equation is known as a regression equation, and the problem of making prediction on the basis of the equation is called a problem of regression. In short, correlation is concerned with the measurement of strength of association between variables, while regression is concerned with the prediction of the most likely value of one variable when the value of other variable is known. In simple correlation and simple regression, also called linear correlation and linear regression, we consider the simplest kind of relationship, which a linear relationship as the regression equation. Some correlation is therefore concerned with the strength of linear type of relation between the variables. So, correlation and regression are the some statistical tools. Two variables are said to be correlated. Two variables are said to be correlated if the change in one variable results in corresponding change in the other variable. The correlation is a statistical tool which studies the relationship between two variables. Correlation analysis involves various methods and techniques used for studying and measuring the extent of correlationship between the two variables. Correlation is concerned with the measurement of strength of association between variables. The degree of association between two or more variables is termed as correlation. Correlation analysis help us to decide the strength of the linear relationship between two variables. The word correlation is used to decide the degree of association between variables. If the variables x and y are so related, the variables in the magnitude of one variable tend to accompanied by variations in the magnitude of the other variable. They are said to be correlated. Thus, correlation is a statistical tool with the help of which we can determine whether or not two or more variables are correlate, and if they are correlated, what is the degree and the direction of correlation. Definition: the correlation is the measure of extent and the direction, direction of the relationship between two variables in a bivariate distribution. For example, height and weight of the children, an increase in the price of commodity by decrease in the quantity demanded. Uh, Types of correlation: the following types of correlation: positive and negative correlation, simple, partial, and multiple correlation, linear and non-linear correlation. Correlation first developed by Sir Francis Galton in 1882, 1911, and then reformulated by Carl Pearson's 1857, 1936. Note, the degree of relationship or association is known as the degree of relationship. Types of correlation: positive and negative correlation. If both the variables are varying in the same direction, that is, if that is if one variable is increasing and the other on an average is also increasing, or if as one variable is decreasing, the other on an average is also decreasing, correlation is said to be positive. If on the other hand the variable is increasing, the other is decreasing, or vice versa, the correlation is said to be negative. Example: heights and weight, amount of rainfall and yields of crops, price and supply of a commodity, income and expenditure on luxury goods, blood pressure and age. Second example: price and demand commodity, sales of woolen garments, and the day's temperature. Simple and partial and multiple correlation: when two variables are studied, it is case of simple correlation. In partial and multiple correlation, three or more variables are studied. In multiple correlation, three or more variables are studied simultaneously. In partial correlation, we have more than two variables, but consider only two variables to be influencing each other, the effect of other variables being kept constant. Linear and non-linear correlation: if change in one variable tends to bear a constant ratio to change in the other variable, the correlation is said to be linear. Correlation is said to be non-linear if the amount of change in one variable does not bear a constant ratio to the amount of change in the other variable. Methods of studying correlation. Correlation is studied by the two methods. One is the graphical method, second is the algebraic method. Graphical method is based on scatter diagram, and algebraic method is based on Carl Pearson's coefficients of correlation. So methods of studying correlation, the following are the methods: scatter diagram method, Carl Pearson coefficient of correlation. First, the scatter diagram. This is the graphic method of finding out relationship between the variables. Given data are plotted on a graph paper in the form of dots. That is, for each pair of x and y values, we put a dot and thus obtain as many dots as the number of observations. The greater the scatter of points over the graph, the lesser the relationship between the variables. This is the scatter diagram representation. In first figure, the perfect positive correlation. In the second figure, perfect negative correlation. Third figure showing the low degree of positive correlation, and the fourth figure shows the low degree of negative correlation. Fifth figure shows the high degree of positive correlation. Sixth shows the high degree of negative correlation, and the seventh shows the no correlation, and eighth is also showing the no correlation. Interpretation: if all the points lie in a straight line, there is either perfect positive or perfect negative correlation. If all the points lie on a straight falling from the lower left hand corner to the upper right hand corner, and the correlation is perfect positive. Perfect positive if r is equals to +1. If all the points lie on a straight line falling from the upper left hand corner to the lower right hand corner, then the correlation is perfect negative. Perfect negative if r is equals to -1. The nearer the points are to be set are to be straight line, the higher degree of correlation. The farther the points from the straight line, the lower degree of correlation. If the points are widely scattered and no trend is revealed, the variables may be uncorrelated, that is, r is equals to 0. The coefficient of correlation. A scatter diagram gives an idea about the types of relationship or association between the variables under study. It does not tell us about the it does not tell about the quantification of the association between the two. In order to quantify the relationship between the variables, a measure called correlation coefficient developed by Carl Pearson It is defined as the measure of the degree to which there is a linear association between two intervally scaled variables. Thus, the coefficient of correlation is a number which indicates to what extent two variables are related, to what extent variations in one go with the variations in other. The symbol R or Rxy or Ryx is denoted in the method is calculated by R equals to covariance x comma y divided by Sx Sy. First, where covariance is the sample covariance between x and y. Mathematically, it is defined by covariance is equals to bracket summation x minus x bar multiplication y minus y bar bracket close divided by n minus 1, or Sx is equals to sample standard deviation of x is given by Sx is equals to bracket summation x minus x bar whole square divided by n minus n minus 1 and to the root. Sy is the sample standard deviation of y, which is given by Sy is equals to summation y minus y bar whole square minus divided by n minus 1 to the whole root. And x bar, we know that x bar is equals to summation x divided by number of observation, and y bar is the summation y divided by the number of observation, that is mean. Interpretation: if the covariance is the positive relation, interpretation if the covariance is positive, the relationship is positive. If the covariance is negative, the relationship is negative. If the covariance is zero, the variables are said to be not correlated. Hence, the covariance measure the strength of a uh, linear association between considered numerical variables. Thus, covariance is the absolute measure of this linear association. In order to have a relative measure of relationship, it is necessary to compute correlation coefficient. Computation of correlation coefficient, a relation developed by Carl Pearson's RS, follows. The formula for sample correlation coefficient R is calculated by the following relationship. R is equals to summation x minus x bar into y minus y bar root summation x minus x bar whole square into root summation y minus y bar whole square. Further, R is equals to, and the formula is showing to you. You can use the manipulated or simplified formulas further for calculating the correlation coefficient. If x minus x bar is equals to x and y minus y bar is equals to y, then the above formula reduces to. So, if we consider x minus x bar is equals to x and y minus y bar equals to y, then the formula for correlation coefficient can be reduced R equals to summation xy root summation x square into root summation y square. Properties of Carl Pearson's coefficient, correlation coefficient. The coefficient of correlation R is always a number between -1 and +1 including -1 and +1. If R is equals to +1 or -1, the sample points lie on a straight line. If R is near to +1 or -1, there is a strong linear association between the variables. If R is small, close to 0, there is a low degree of correlation between the variables. The coefficient of correlation is the geometric mean of the two regression coefficient. Symbolically, R is equals to root bxy minus bxy multiply byx. Note, it is clear the correlation coefficient is a measure of degree to which the association between the two variables approaches a linear function relationship. Interpretation of correlation coefficient. The coefficient of correlation obtained by above formula shall always lie between -1 or +1 to -1. Uh, if R is equals to +1, there is a perfect positive correlation between the variables. If R is equals to -1, there is a perfect negative correlation between the variables. When R is equals to 0, there is no correlation. When R is equals to 0.7 to 0.999, there is a high degree of correlation. When R is equals to 0.5 to 0.699, there is a moderate degree of correlation. When R is less than 0.5, there is a low degree of correlation. The value of correlation lies between -1 to +1. That is, R is less than or R is greater than or equal to -1 or less than or equal to +1. The correlation coefficient is independent of the choice of both origin and the scale of observation. Uh, the correlation coefficient is a pure number. It is independent of the units of measurement. Coefficient of determination. The coefficient of determination, R square, is the square of the coefficient of correlation. It is a measure of the strength of the relationship between two variables. It is subject to more precise interpretation because it can be presented as proportion or as percentage. The coefficient of determination gives the ratio of the explained variance to the total variance. Thus, coefficient of determination R square is equals to explained variance divided by total variance. Thus, coefficient of determination shows the what amount of variability or change in independent variable is accounted for by the variability of the dependent variable. Example, first, if R is equals to 0.8, then R square is equals to 0.8 square is equals to 0.64 or 64%. This means that based on the sample, 64% of the variation in dependent variable y is caused by the variation of the independent variable x. The remaining 36% variation in y is unexplained by the variation in x. In other words, the variation other than x could have caused the remaining 36% variation in y. Example 2, while comparing two correlation coefficient, one of which is 0.4 and the other is 0.8, it is misleading to the conclude that the correlation in the second case is twice as high as correlation in the first case. The coefficient of determination clearly explains this viewpoint, since in the case R equals to 0.4, the coefficient of determination is R square is equals to 0.16, and in the case R is equals to 0.8, the coefficient of determination is equals to 0.64, from which we conclude that correlation in the second case is 4 times as high as the correlation in the first case. If the value of R is equals to 0.8, we cannot conclude that 80% of the variation in the relative series dependent variables, but the coefficient of determination in this case is R square is equals to 0.64, which implies that only 64% of the variation in the relative series has been explained by the subject series, and the remaining 36% of the variation is due to the other factor. Thrice a time that is equal in frequency. So these two are the modes. Grouped data. For discrete distribution, see the highest frequency and corresponding value of x is mode. For discrete distribution, that is grouped data or the tabular form data is given, then the mode is directly can be calculated by observing the frequency, which is directly given to you. Weight of the sorghum in grams, 50 gram. Number of year had 4, 65 6, 75 16, 88, 95 7, 104. So 75 is repeating 16 times, which is very high frequency other than the other weights. So the maximum frequency is 16, the corresponding value, the corresponding x value is 75. Therefore, the mode is equals to 75 grams. Now continuous data or continuous distribution. Locate the highest frequency, the class corresponding to that frequency is called the modal class. Then apply the formula. Mode equals to L plus Fs upon Fp plus Fs into C, where L stands for lower limit of the modal class, Fp stands for the frequency of the class preceding to the model class, Fs is the frequency of the class succeeding to the model class, and C equals to the class interval. So, if any data is provided into the form of class distribution or continuous distribution, and locate the highest frequency class corresponding to that frequency called the modal class. So then apply the formula like this, and we need to find out the lower limit of the modal class. First of all, we are going to find out the modal class. For example, just in the example, you see that if frequency distribution of weights of sorghum ear heads given in a table, calculate the mode. Weights of ear heads 60 to 80, 22, 80 to 100, 38, 100 to 120, 45, 120 to 40, 140, 35, 140 to 160, 20. So, as by observing the table, the number of ear heads 45 is more for the range 100 to 120. So, this is decided as the modal class. First of all, this is decided as the modal class. Okay. After deciding the model class, now put everything according to the formula. So L is the lower limit or lower range of the model class. So 100, L equals to 100, and F equals to 45. That is the highest frequency. C equals to the difference between the model class. That is 120 minus 100. It come out to be 20, and M equals to 60. M equals to 60, and Fp equals to 38. That is the frequency preceding to the or to the model class 38, and to the 35, that is further further model class value. Now put all these values. 100, that is L, plus lower frequency 35, 38 plus 35 into 20. So the answer come out to be 109.589. So this is the mode. Now quartiles. Quartiles are just like a percentile and all that. Percentile means that you divide into the 100. So similarly to that, the quartile divide the distribution into four parts. There are three quartiles. The second quartile divides the distribution into two halves, and therefore is the same as the median. The first lower quartile Q1 marks of the first 1/4, the third upper quartile Q3 marks of the 3/4. It may be noted that the second quartile is the value of the median and the 50th percentile, raw or ungrouped data. So, for finding the quartile deviation or quartile division for raw or ungrouped data, first arrange the given data in the increasing order and use the formula for Q1 and Q3. Then quartile deviation QD is given by QD is equals to Q3 minus Q1 by 2, where Q1 is calculated as n plus 1 by fourth item, and Q3 is equals to 3 n plus 1 by fourth item. Okay, so first you calculate the Q1 and Q3. After that, quartile deviation is the difference between Q3 and Q1 divided by 2, that is the average. Now these are the some questions or the quiz related to the part we had covered. So the middle value of an ordered series is called second quartile, fifth decile, fifth percentile. all the above. So the middle value of an order series is called, it can be second quartile, it can be fifth decile, it can be fifth percentile. That's mean the D option, all the above, is correct option. For a set of values, the modal value can be unimodal, bimodal, trimodal. I'm repeating the question once again. For a set of values, the modal value can be unimodal, bimodal, trimodal. It can be anything. So all of these, all of the above. The D option is correct. Third is mode is suitable for qualitative data. Yes, we had studied the merits and demerits, where there we had to find that mode is suitable for qualitative data. Yes, it is true. Decile divides a group into 10 equal parts. Yes, obviously, decile, percentile, I had already told you that it divides into 100 parts. So decile divides the group into 10 equal parts. True. Mean is affected by extreme values. Is it true or false? Yes, is it true? Mean is always, that is, average is always by the extreme values. Geometric mean can be calculated for negative values. Yes, it can be calculated for negative values. Now, these are some theoretical questions which you need to write by your own understanding of the topic. Define mean and median. For what type of data mode can be calculated? Explain how to calculate the arithmetic mean for raw and grouped data. Explain how to calculate median and mode for grouped data. So this is all about the mean, median, modes. And now we are going to start with another topic. So we will start in the next lecture, that is the measure of dispersion, range, variance, standard deviation, coefficient of variation, computation of the above strategies for raw and grouped data. So this will be started in the next lecture. And just for today, thank you. Thank you to all of you. Now, measure of dispersion. In statics, dispersion, also called variability, scattered or scatterness or spread, is the extent to which a distribution is stretched or squeezed. Common example of measure of statistical dispersions are the variance, standard deviation, and interquartile range. Dispersion is contrasted with location or central tendency, and together they are the most used property of distributions. So a measure of statistical dispersion is non-negative real number, that is zero if all the data are same, and increases as the data become more diverse. Most measures of dispersion have the same units as the quantity being measured. In other words, if the measurement are in meters or second, so the measure of dispersion. Example of dispersion measures include standard deviation, interquartile range, mean absolute difference, also known as Gini, mean absolute difference, median absolute deviation, average absolute deviation, distance standard deviation. These are frequently used as estimators of scale parameters, in which capacity they are called estimates of scale. Robust measures of scales are those unaffected by small number of outliers and include the IQR and MAD. All the above measures of statistical dispersion have the useful property that they are location invariant and linear in scale. This means that if a random variable has dispersion that is ignored if proceeding negative. Other measure of dispersion are dimensionless. In other words, they have units even if the variable itself has units. Now, to understand the dispersion, the averages are representatives of the frequency distribution. We had seen the or we had studied the various averages, but they fail to give a complete picture of the distribution. They do not tell do not tell anything about the scatterness of the observation within the distribution. Suppose that we have the distribution of the yield. Suppose that we have the distribution. Suppose that we have the distribution of the yield per plot, kg per plot, of two paddy varieties from 5 plots each. The distribution may be as follows. Variety first and variety second in different 5 plots or in different 5 beds are given. When we are going to take out the average of these 5 distribution, it can be seen that the mean yield for both varieties is 42 kg, but cannot say that the performance of two varieties are same. There is a greater uniformity of yields in the first variety, where there is a more variability in the yields of the second variety. The first variety may be preferred since it is more consistent in yield performance. Uh, from the above example, it is obvious that measure of central tendency alone is not sufficient to describe a frequency distribution. I'll let you give one more example or a live example. Suppose if I'm talking or if I'm taking an example of three families. Three family are having the different family members. The number of family members are different, and their incomes of each family members are also different. And suppose if we know that, or if we want to calculate it, the average income of each family, then it is found to be equal in all the respect. So where there is a variance or where there is a difference in the family members of each family, and there is a variation in their income also, but the average come out to be the same. So we can directly say that the average alone cannot give or not sufficient to describe the frequency distribution. In addition to it, we would have a measure of scatterness of observation. The scatterness or variation of observation from their average are called the dispersion. So, what do you mean by the dispersion? The basic mean of or the basic definition of the dispersion is the scatterness or variation of observation from their average are called the dispersion. There are different measures of dispersion like the range, quartile deviation, mean deviation, and the standard deviation. I had already told you. Now, what are the characteristics of good measure of dispersion? An ideal measure of dispersion is expected to possess the following properties. It should be rigidly defined. It should be based on all the items. It should not be unduly affected by extreme items. It should lend itself for algebraic manipulation. It should be simple to understand and easy to calculate. These are the some good characteristic of measure of dispersion. Entropy and the dispersion are almost same word. Entropy, while the entropy of the discrete variable is location invariant and scale independent, and therefore not a measure of dispersion in the above senses. The entropy of continuous variable is location invariant and additive in scale. If Hertz is the entropy of continuous variable Hz and Z, then there are two measures of dispersion, variance and variance to mean ratio. So entropy is the degree of randomness. For categorical variables, it is less common to measure dispersion by a single number. The qualitative variation, one measure that does not or that it does so, is the discrete entropy. Now, the first measure of dispersion, that is range. It is the simplest possible measure of dispersion and is defined as the difference between the largest and the smallest values of the variable. In symbols, range is written as largest minus smallest. In individual observation and discrete series, largest and smallest are easily identified. In continuous series, the following two methods are followed. As we had discussed, the data or the observations are given in basic three type of categories. First is the raw data or ungrouped data. Second is the frequency distributed data. And third is the class range frequency distributed data. So in raw data and ungrouped data, the range calculation is so easy. By the observation, you just subtract the largest value to the smallest value and you get the range. But in the case of frequency distributed data or in the class frequency distributed data, you need to do the calculation somewhat by choosing the higher frequency as the largest and the lowest frequency as the smallest. Now, for example, if you take an example for the raw data, a series or observation is given in front of you 8, 9, 8, 10, 10, 11. So, by observing this, the highest value is 11 and the lowest value is 8. So, the range is given as 11 minus 8, come out to be 3. Now, if I'm talking about example 2, the distribution or the data is given in the frequency class distribution range 60 to 63. The size is of 60 to 63, having 5 number of frequencies 62 to 66 and so on. So we have to choose the upper boundary of the highest class and lower boundary of the lowest class. So the highest boundary having the highest number is 75 and the lowest class is having the smallest number 60. So the range is given as 75 minus 60, that come out to be 50. Now, merits and demerits of range. It is simple to understand, it is easy to calculate. In certain types of problems like quality control, weather forecast, share price analysis, etc., range is most widely used. Demerits, it is very much affected by the extreme items. It is based on only two extreme observations. It cannot be calculated from open-end class intervals. It is not suitable for mathematical treatment. It is a very rarely used measure. Now, standard deviation. It is defined as the positive square root of the arithmetic mean of the square of the deviation of the given observations from their arithmetic mean. So the standard deviation is having the definition in accordance to the formula. So analyze the formula carefully and remember the formula very carefully and work on the data and the observation given to you and put the all values of the data in the formula and get the solution for standard deviation. Here standard deviation formula for the raw data is given summation x square minus summation x to the whole square by n upon n minus 1 under the root. This formula is for the raw data. Now this is for the discrete data and the third formula is for the continuous type of data. So please note down the formulas according to the different types of observations or data provided to you, because standard deviation is totally depending on the formula and the calculation. And now we are moving for the some examples. This is the example given for the raw data and you need to find out the standard deviation. So as per according to the formula, we are going to create the table, arrange the data in the columns, and according to the formula, create the table, introduce the columns, do the totaling, and put all the totaling because the summation words are to be used in the formula. So here we require the sum. So put the summation and divide it by the number of observation. You are able to get the solution. So the standard deviation for the above example come out to be 12.25 grams. Now the standard deviation for the frequency distribution type data or discrete distribution type data, the seed yield in grams 3, 4, 5, 6, 7 and the frequency 4, 6, 15, 15, 10 is given to you. Now use the formula, create the table, and according to the formula, introduce the column in the table and do the summation of all the data in the last row, that is total. And when we add the frequency, it come out to be 50, that is total number of observation. The value of n is 50. Put all the values in the formula. Finally, you got the solution which come out to be 1.1677 grams is the standard deviation for the given discrete distribution type data. Now, for continuous type distribution data, the frequency distribution of yield of the 50 shisham plants are given below. In the range of 2.5 to 3.5, 4 plants. In the range of 3.5 to 4.5, seed yields in grams is given by 6 plants. And similarly, in the range of 4.5 to 5.5, in the range of 5.5, 6.5, and in the range of 6.5 to 7.5. Now, according to the formula, create the table, arrange the table in the table, arrange the data in the table, and according to the formula, create the columns and do the totaling in the last row and put all the values in the formula. Have a look for this. And while putting and doing the calculation, care must be taken And when you put all the data in the formula for the standard deviation for class distribution type data, for the above example, the standard deviation come out to be 1.1677. So this is all about the standard deviation, and we had seen the examples related to the standard deviation for all the three types of data. Now the merits and demerits of standard deviation. Merits, it is rigidly defined and its value is always definite and based on all the observation, and the actual sign of deviations are used. As it is based on arithmetic mean, it has all the merits of arithmetic mean. It is the most important widely used measure of dispersion. It is possible for further algebraic treatment. It is less affected by fluctuation of sampling and hence stable. It is the basis for measuring the coefficient of correlation and sampling. Now demerits. It is not easy to understand and it is difficult to calculate. It gives more weight to extreme values because the values are squared up. As it has an absolute measure of variability, it cannot be used for the purpose of comparison. So these are the merits and demerits of standard deviation. Now we are going to start with variance in the next lecture. So thank you all for today's lecture. We will discuss variance, coefficient of variance in the next lecture. Thank you all.